Hi everyone, thank you for joining us here today. I'm Sophie Reay, Sales Associate here at Atelerix, and I'm really excited to be hosting today's webinar, which explores our collaboration with Labskin and showcases some of their recent work using our technology. Our presenters today include Dr. Steve Swioklo, CSO and co-founder of Atelerix. We also have Hugh Mead here, who is Head of Biology at Labskin Limited. And our webinar today is titled Lab to Lab, Keeping Labskin's Full Thickness Model Alive on Our Journey. The presentation will be around 30 minutes long, and this will be followed by a Q&A session. So feel free to drop any of your questions in the Q&A box below, and we can discuss those at the end. So over to you, Hugh.
Thank you, Sophie. So I head up the tissue culture unit at Labskin, and I'm going to give a bit of intro into Labskin and what we do before moving on to talking about how we interact with the Atelerix. So Labskin is a full thickness human skin equivalent. It's had quite a colourful history. It was first developed back at the University of Leeds, and it was developed as a platform for studying the microbiome. And that's kind of what sets us apart, our unique selling point, the ability to culture the microbiome on top of the model, and not only place it on there, but grow it and show how it interacts between the different microbes that we can put on and between the cells of the skin, which is kind of really crucial because that interplay is really, it's a big part of how the microbiome interacts with the human skin. Developed nearly 16 years ago now. It's passed hands as a tech a few times, and in that period, it's developed over 30 publications, looking at the skin. Most recently, we interacted with a project with the CDC, with the IARPA, looking at how radiation impacts the microbiome. But really, we think that anything you can put on skin, anything you want to see how it interacts with skin or the microbiome of skin, we can do. We do a lot of work with cosmetics brands and healthcare, but we're looking to get into pharmaceuticals and other parts like that. Moving on to the next slide. So this is Labskin. It's grown on a fibrin gel, so the same process that creates a blood clot in your body, we utilize that to create the gel. And within there, we cast primary dermal fibroblasts, culture them, and then we place primary human keratinocytes on top, culture it for 2 days submerged, and then raise it to the air liquid interface, which is just a fancy way of saying we dry the tops, and that imitates the environment that exists in the in vivo of human skin. And then we culture it for 12 days at the ALI, and that develops our full thickness model. We have two main products. We have the 6 wells on the top there. These are really good for anything that you want with a larger surface area. But they've been predominantly, and that was originally what it was developed as, that was the size it was originally developed, but it's been mostly replaced by the 12 wells due to the nature of the fact that you get more constructs in a plate, you can do more tests and more repeats. And what we found is most of our work is done as a CRO in-house due to the expertise we have of working with the microbiome on the skin model. But some clients like to purchase it and have it delivered and get to do the work themselves. And this is kind of where difficulties start to arise because they're grown in a transwell insert placed in the media. This is really crucial because all the nutrients that they get come from there. But due to uncertainties around how couriers carry it, we're obviously unable to ship it within the media. So this is kind of where things start to get a bit difficult. We were previously shipping it in an agarose DMA mix to allow it to be fixed in place as a gel and have some nutrients, but it didn't give us a lot of time to work with. So when things went well and shipments went smoothly, it wasn't a problem. But if there's ever ever issues that I'm sure most of us have experienced with couriers and customs and what have you. This is where things started to break down, because it needed to be a really smooth process within a certain time frame, because it is a living model that interacts and needs to survive and needs to have those nutrients to continue to function. So we had a really small time window to work with to get that to clients. And if you take me to the next slide, please. And this is why. Whilst the model is really robust and really closely represents human skin, you can see the structure in the top left there. We get that thick stratum corneum with the three layers of the epidermis below it, with live fibroblasts that put down their own ECM into the fibrin gel. And then we get really close protein expression when you compare it to human skin. We have some structural markers on the bottom there for the first four. And then the last two images are what allow us to do a lot of the microbiome work. Because the model is living, it produces its own antimicrobial peptides, which allow that interplay and the crosstalk, which allow us to maintain and grow the microbiome on top. And to make sure that the work that the client does is representative of human skin, we need to make sure that structure, that protein expression, that function is maintained throughout shipping, and making sure that when it arrives to the client, it is still representative of human skin, and that the data they generate is representative. So yeah, it's a difficult process to get it there in time. When it worked well, it was great, but we found that we had about a time frame of 48 hours to 72 hours to work with, and that was when we started to look for alternatives this time, and that was when Atelerix popped up on our radar. And I'll allow them to kind of explain what they do, so handing over to Steve.
Thank you very much, Hugh. Hugh just gave a very, very good introduction to the advanced cell-based models that they provide, and also some of the issues that come around when you try to ship them to clients, and it can be quite a hurdle at some points. And Hugh's advanced models really kind of fall under the umbrella of new approach methodologies. Hugh described some of the cosmetics, but some of the applications, including cosmetics and drug discovery. And they're really being increasingly encouraged in drug development and IND submissions currently. There's a number of different advanced models or NAMs, including celluloids, organoids, bioprinted or engineered tissues, scaffold-based models, and organ on a chip. But really, all of these are designed to recapitulate the complex 3D architecture and cell behavior of tissue and organ systems. Next slide, please, Sophie. But one of the problems when you try to increase complexity and physiological relevancy, it often increases the fragility of those models. They're more complex, there's a lot more going on, and it's a lot more difficult to transport using conventional methods such as freezing, which has historically been used for cells. And what this does mean is that the survivability and stability during shipment is often compromised. You often get a lot of models that are not functioning properly when they arrive at their destination. And it really kind of inhibits the accessibility and harmonization of those models. And Atelerix is here to say that it doesn't have to be this way. Next slide, please. We offer a cryo-free, hassle-free ambient logistics solution, which amplifies fresh sample shelf life from hours to weeks. We supply biosample preservation kits, which are quick and easy to use. And what these do is maintain sample viability and functional performance after room temperature, shipment, and storage. And this enables complex tissues, blood, sensitive cells, and therapies to be shipped. And very much in the context of this webinar, advanced complex in vitro models. The products are easy to validate, they de-escalate shipping, and they can be rolled out across workflows. Our products work using specific formulations of alginate hydrogels. And what these alginate hydrogels do is they offer superior cytoprotection during hypothermic storage. And what I mean by hypothermic storage is any temperature below physiological temperatures, so those you would find in the body or incubator, but above freezing. And what the gels actually do is stabilize cell membrane integrity. And cell membrane integrity is often the first thing to go when you try to keep samples alive outside the body or incubator. Essentially, they become porous. There's uncontrolled transport of components into the cell. They fall apart, they burst, and they don't last very long. So our gels prevent this process, allowing them to be held at room temperature or refrigerated temperatures for extended periods. Because they work on the lipid membrane, they can be applied to everything from cells to viruses to tissues to blood products, essentially any biological material that has lipid membrane components. And importantly, Q discussed not being able to ship in medium because the FedEx or DHL driver may just lob the box upside down in the back of the van. Our gels are additionally formulated for optimal mechanical protection. And what this does, it prevents any shear forces from liquid movement disrupting the cell model. And it also buffers those mechanical forces, those vibrational and drop shock forces, which often occur if you're trying to move samples across the globe. Next slide, please. So the aim of this collaboration with Labskin was to evaluate WellReady's performance in stabilizing Labskin S, their main model, during storage and shipment, and needed to ensure that model integrity and function is retained to really extend and enable global distribution, increase that shelf life past the 2 to 3 day time mark to really buffer the global distribution and potential holdups which occur during shipping of these models. And with that, I will pass back to Hugh, who will walk through some of the outcomes from that pilot trial.
Thank you, Steve. Yeah, as you said, the models becoming more complex is certainly an issue when it gets to shipping. And looking at the data we generated from our experiment, we first wanted to look at a time course to see how it lined up against our current shipping method. Along the bottom in this figure, you've got our current shipping method. Well, I say our old shipping method now. And as you see, around 48 hours, you've still got a pretty structurally sound model. But following that, we start to see degradation of the model. The sternum corneum starting to break down. The cells in the epidermis are dying. Those basal level cells that feed the epidermis are starting to die. And those are what we really crucially want to survive. And even in the dermis, the hardy fibroblasts that we think are a very robust cell type are starting to see forms of degradation. The staining's less pronounced, and signs of cell death are there. Now, when we look at the Atelerix, that is not quite, it's a very different story. So around the 48-hour to 72 mark, it's still looking really robust. So we can already say it's already at least as good as our old shipping method. But what really impressed us is when you start getting to the 96 and 120 hours, and you're really only seeing very minimal signs of degradation at all, very few signs of stress. Those basal level cells are still looking healthy. The thickness of the sternum corneum's there. And it really started to show that Atelerix was able to prevent that degradation of cells and protect the cell membrane over those longer periods of time. So following that time course, we wanted to dive a bit deeper and make sure that the data we were seeing at those longer time points was correct. And that'll bring me to my next slide. Fantastic. So we did a repeat with more constructs to bolster our data. And in the agarose, our control, the images are really pronounced. You're starting to get big gaps emerging in the model on those top two at 96, and then even worse at 120 hours. The model is thinned. There's basically no signs of nuclei or really healthy cells. And this lines up with what we've seen in the past. Whenever shipments that we send out get caught up in customs, it starts to break down around the 3 or 4 day mark, and it essentially ruins the plate. It ruins the model. It ruins the product that the clients purchase, because any data generated from these models just isn't representative, because you'll be getting high signs of stress, production of cytokines and inflammation in the model, which will skew the data that they're looking at. And even especially in the 120 hours, we're starting to see degradation of the fibrin gel, which you can see in that shrinkage with the in the bottom left image at the 120 hours. That transwell membrane starting to become apparent in the image. And then when you compare that to the Atelerix, the staining in the epidermis is much more pronounced. You've still got healthy nuclei. You've still got healthy cells in the basal layer. That sternum corneum is still looking nice and thick and representative of human skin. And those fibroblasts are still nice and pronounced. They're healthy. They're alive. They're still able to put down those ECM proteins that make Labskin physiologically relevant to human skin. And it means that the data that they'll get, the data the client will get, will be actually what it's supposed to be. And with all that in mind, after seeing the structure was maintained, we wanted to make sure the function of our model was still there. And as I said earlier, the unique selling point of Labskin is the ability to not only put microbes on top, but culture them and see how they interplay with each other and the cells in the human skin, and get that more complex, physiologically relevant environment to generate data from. So that brings me to my next slide. So a lot of what we do is getting colony forming units from the model. We'll seed, in this case, C. acnes, C. striatum, and S. epidermidis. And they represent our 3X mix. So we put together both a 3X and a 6X mix, and we think these most closely represent the microbiome in human skin. Obviously, it depends. Things like age, gender, ethnicity all play a part in the composition of your microbiome, but this is what we think is the most relevant to us. And as you can see, when compared across the board, C. acnes and C. striatum are pretty much the same. There's no statistical significance between the two, with really tight data points in C. acnes. Comparable to our old shipping method. There is a small spike in S. epidermidis. They both our shipping types have it. So it didn't seem to stand out as something that Atelerix was doing. And actually, this is what kind of leads us on to some more research that we're looking into. So part of what we saw from this is that they were colonized shortly after taking out of the shipping environment, and actually that causes some, and we believe that's the case for the S. epidermidis, and that's causing the spike when compared to our control that's done straight from finishing culture to the services guys doing their work on it. So across the board, we're really happy seeing that our model can not only still be used structurally, what we're looking at, but the function that is what sets apart from our competitors is still maintained, and is still allow our our clients to do work on that. And that brings me to the end of that one.
Thank you very much, Hugh. That was really good and compelling data. And just this final slide to conclude that Labskin S can now be preserved for longer to enable global distribution. And there's in the bottom right-hand corner there a packaged up Labskin which was ready to go earlier this week, I believe, to the States, and it's now being used in full force. So if you are interested in accessing Labskin S for your development work, whether it be any of the multitudes of applications that Labskin offers, please get in contact with Hugh. His email is just there, hughmead@labskin.co.uk. And if you yourselves have any tricky cell models or biospecimens that you need to store and or ship, you can contact Sophie Reay at atelerix.co.uk. Sophie is presenting this webinar. And with that, I will hand back to Sophie, who will lead the Q&A.
Great. Thank you both for your informative presentation. So now we'll move on to the Q&A part of this webinar. So for our first question, this question is for Hugh. And the question is, what are the main challenges when transporting a full thickness skin model like Labskin between labs?
Sure. So the big thing that I found from the research that we've done looking into it is that a number of factors kind of interplay, because the models are grown in tight conditions in an incubator. So you've got CO2, you've got temperature, and you've got nutrients. We can maintain the temperature pretty well. There's pretty good tech out there for shipping scientific, medical aspects. So that was never too much of an issue. And the model is fairly robust in terms of temperature fluctuations within reason. I wouldn't be putting it in the fridge and hoping that it still functions as it did. But in terms of fluctuations between ambient temperature, it is fairly robust there. CO2 isn't too much of a big deal, again, because we're not looking in the shipment time at maintaining that pH. But the availability of nutrients was a really crucial thing. And we think that was the big reason for a degradation of around 48, 72 hours, because we change the media every 48 to 72 hours. We do it Monday, Wednesday, Friday, and then it's fine over the weekend. But if it doesn't get access to those fresh nutrients after that time frame, we see the degradation that we see. So having it being able to be encased with what Atelerix brings to maintain that cell membrane, I think is what's really crucial from preventing that breakdown of the cells and allowing us to have that extended period. And I think the challenges arise mostly because most shipments can happen within about that 48, 72 hours. But it's when issues arise with things like customs or missing flights or anything like that, that's when the logistics chain breaks down. And that's when our model starts to degrade. And funnily enough, our first shipment that went out with the Atelerix this week to America has unfortunately been stuck in customs. So the trial run for Atelerix may end up being really useful in this circumstance. So shipping locally within the UK, within Europe, isn't too bad. Obviously, with Brexit, getting things through into Europe has got a little bit more challenging. But places like the States or Asia is where things start to get very difficult with customs and the longer shipments. So that's where I think Atelerix is really going to shine for us.
Very
Great,
good.
thank you.
No, just to add to that, really, you can have expedited shipment with really quite expensive couriers. It can go into thousands. And what we help out a lot with is people reducing those costs so that they can just use generic couriers, which, yes, they're more likely to get stuck, but because we provide that buffer, it doesn't actually affect their models too much. And Hugh, you're not the first person to have stuff stuck in customs using our materials. It's a common occurrence, unfortunately, in especially in this global world. It's getting a lot more complicated to ship stuff around.
Great. So our next question is for you, Steve, and it is, are there any limitations or special handling requirements when using ambient shipment, ambient temperature preservation methods?
Um, The only thing that you've got to be careful of, so um, with advanced models, Well Ready is very good at keeping the models stabilized. There's medium in with the gel that provides the low level of metabolic substrates that are required to keep cells alive, and what is a very slow rate of metabolic activity, but it's still not completely squashed by hypothermic or room temperature storage. The main thing is just to be aware of avoidance of temperature fluctuations. Often these occur on long-haul international flights or routes that have depots or holds at temperatures that can go up to about 40 degrees, especially when you're shipping to APAC, like India, Saudi. So what we do advise is that you ship with really quite straightforward uh, controlled ambient boxes or controlled room temperature boxes, which just buffer those deviations in temperature. Um, these are very widely available. They've been used for pharmaceutical delivery for decades, and essentially they're just small styrofoam boxes with phase change material packs that prevent that buffer. That's the main kind of consideration you've got to make. Obviously, it's always wise to, as Hugh has done, do an evaluation of our products to ensure that you're not storing for too long or you haven't got the storage conditions right. But often they're very straightforward to conduct, and we're always happy to support with those initial evaluations.
Okay, great. And our next question is for you again, Steve. Can this preservation method be applied to other tissue types or 3D models beyond skin?
Yes, we've got a number of users preserving organoids, cancer-derived organoids, and iPSC-derived organoids. The interest in using our products to distribute those is just shooting up, but that's really in line with other advanced complex models such as Hugh's. Um, Also, in plate assays when they are within culture inserts or airlifted models. Essentially, it spans the whole gambit. I mean, what we're seeing is just a big escalation in interest as the models just start to increase. I think we know of essentially everything from large companies to innovative companies such as Hughes are just really kind of getting these models out there, getting them in people's hands for full utilization in drug discovery and other applications now. So um, uh, essentially, if you want to kind of have a rule of thumb, if it's got a lipid membrane, we can generally preserve it. That's a bit
Great.
oversimplified, but it works.
So here the next question is for you. Why might conventional methods not be the optimal approach for shipping complex 3D tissue models?
Good question. Um, for us, I think the conventional methods meant that everything had to be done in such a short time frame. Steve touched on the necessity for complex models and the desire for them. And he's not wrong in that it is starting to become more and more popular to have access or want access to these complex models because they are just so much more representative than cells in a flask or microbes in a shake flask or whatever it might be. And I think the shipping of these is yet to kind of catch up. The current methods are get it there as soon as possible, which just isn't really feasible all the time. And I think I didn't know Atelerix existed until about a year ago, but it seems like this is what would be the next step to make our shipments give us more confidence in our ability to ship and make our methods of shipping far more robust. Yeah.
That brings us nicely to our next question, which is, do you foresee this approach becoming standard for commercial distribution of 3D tissue models? And what are the next steps for broader adoption?
Yeah, I do see stuff like this as taking a bigger step, because it just gives you that buffer, which just allows you to feel a little bit more confident, allows you to sleep at night after you've sent that shipment out. Yeah, I think with the adoption of and the use of widespread of these models, there needs to be confidence in your ability to ship, and just saying let's get it there ASAP. It doesn't fill you full of confidence. You're constantly following up with the courier. You're constantly checking. And I would employ everybody who is working with cells or 3D models to start to do this. I think most people, in terms of wider spread adoption, I think most people who have experience working with things like this, shipping things, biological reagents, biological materials, complex models and cells, appreciates the stress that comes alongside it. And I think it's really only a matter of time before more robust shipping methods like this just become the norm. Awareness is obviously a big part of it, getting people aware that this stuff exists. So I guess that boils down to marketing and things like that. But I think when it's on people's radar, obviously, as Steve said, it's important to test it to make sure it is appropriate for your whatever your model is that you're looking to ship. But based on the data that we generated for ours, we were really impressed by it. And I think, yeah, it's only a matter of time before people start to think about different ways to ship and feel more confident in the in the shipping process.
Yeah, I think it's also important just to kind of highlight the amount of knowledge and skill that companies such as Labskin have in developing their own models. Classically, you would have someone who would provide some cells, some plates, and some medium so that a user would make their own model, be that a insert model or a scaffold model or an organoid model. But there are a lot of issues with that. There's long culture times. There's the high skill required to actually generate those models. There's a chance of things going wrong, which is very, very high when it's not within a controlled environment. So, kind of, this all culminates in everyone using a totally different model all the time. I think the big drive at the moment is harmonization of cell-based models, having that expertise that is able to get to someone else's lab for the different testing or other applications that say Labskin may not offer. So I think it just facilitates all of that, and I think it's the next stage, really. It's the next generation of widespread utilization of such models.
Yeah, I agreed.
Great. And our final question is for you, Steve. Are processes for encapsulation automatable?
Yes, they are. The all of our products actually, this is highlighted well already, but all of our products just involve liquid handling, and therefore they've all been demonstrated to be uh, compatible with basic liquid handlers. Anything from semi-automatic, automated liquid handlers up to larger robots, there is no problem with actually scaling using automation.
I'd like to just chip in on that as well. The ease at which using Atelerix, I was very impressed by. As Steve said, it is predominantly just liquid handling, and it really just boiled down to a step-by-step addition of liquids. So yeah, can attest to the straightforward nature of the product.
Great, thank you. Well, that brings us to the end of our webinar. Thank you very much for joining us. Thank you, Hugh. Thank you, Steve. If you do have any additional questions that you can think of later on, feel free to get in touch with either myself or Hugh. Yeah, looking forward to hearing from you, and we'll see you in our next webinar. Thank you for joining.
Thank you.
Thanks, guys.